Okay, today we want to do a quick review of significant figures. Okay, and I think the first thing we have to talk about one more time is why do we even use significant figures? They're such a headache. But when you're working in science, you have to explain how precise or accurate, to what level of uncertainty the tool of measurement that you use was. Your calculations can't be any better than your measurements. And so to kind of demonstrate that a little bit better, if I'm using this stick that's a meter long and I want to measure this picture frame, okay, I have to read between the lines and round 1/10 past what this thing is marked to. It's only marked to a meter. So the best that I can do is read this to 1/10 of a meter. Okay? Now, if I use a meter stick that's marked to not just the centimeter, which is 100th of a meter, but to the millimeter, okay, now I could read this thing to 1/10,000th of a meter. Okay? So when I write down my measurement, even if it hits right at, let's say it hits right at 20 centimeters, okay, if I use this and I eyeball it and say, that looks like 20 centimeters, okay, I have to show that differently than if I use this tool of measurement and say, well, yeah, it hits exactly on 20 centimeters, which it doesn't, but just for discussion. Okay, so we use sig figs because in science we have to say where our measurement came from and to what level of uncertainty did we go with that measurement. Okay, so rules for significant figures. Okay, there are some things that tell us that thing, that number, that unit is significant. Okay, and then there are times where it screams, no, it's not significant. So let's make that list. Okay, so any non-zero number that shows up in a number is considered significant. So if I had 312, that would be 3 sig figs. Okay? If I have 4,578, 1, 2, 3, 4, 4 sig figs, and we'll just write SF for now on. Okay, so any non-zero. Okay, our first rule is that if you have a non-zero, it's significant. Okay, our next rule has to do with zeros, and we have actually 3 rules we have to talk about with zeros. Okay, the first thing is a trapped zero. A trapped zero is always significant. Okay, the term trapped means between non-zeros. 307. Okay, that's a trapped zero. Okay, if I have 6,001, those are 2 trapped zeros. Okay, those count as significant. So we're looking at 3 and we're looking at 4 sig figs. Okay? Alright, now, in the not significant category is where we get our third rule. Okay? And those are leading zeros. Okay? A leading zero is a zero out in front. Now, we never see them without a decimal, but that's 10, right? Okay? So, or we could say that's still 45. Okay, now wherever we put a decimal, we don't care. The only thing that those zeros do now is they tie the tens place to the label that you're using on that measurement. Okay, so leading zeros are misleading. These do not count. Okay, so in terms of significant figures, we'll leave the top one alone because we don't have a rule for that yet. Let's talk about that last zero, but this is 2 sig figs because those leading zeros don't count. Alright? Now, our fourth rule, okay, really splits into 2 categories. So we got 4, we've got rule 5, and they talk about trailing zeros. Okay? Trailing zeros without a decimal are insignificant. They don't count. Okay? So in other words, we're talking about 250,000, okay, that was rounded to this place, which means there's only 2 sig figs in this number. Okay? Now, if we put a decimal in there, now that trailing zero is showing where we rounded to. So if we have trailing zeros with a decimal, okay, and those are significant. And we'll go over and look at some problems with that here in a second. Okay, our last rule that we have in terms of defining a significant figure is that definitions, also known as exact numbers, have no sig figs. Oops, sig figs. Okay, so in other words, if you're talking about 1 mole is 6.02 times 10 to the 23rd atoms, all bets are off. We don't use those for sig figs. We use the measurement that we get from that, okay, or apply to that. So we're going to move over here and look at some problems and some examples of sig fig rules. Okay, we got a list of 5 different numbers here, and we're going to talk about the number of sig figs that are found. We'll talk about the rules that apply. Okay, so when we look at the top one here, 8,542, all of those are non-zeros, therefore they're all significant. Okay, so this would be, go ahead and pause it for a second. In fact, what you could probably do is go through here and real quick, pause it, and why don't you try and answer those 5, and then we'll real quick go through and discuss those. So we'll wait a second for that. Okay, so we've got all non-zeros here. Okay, so what we're looking at is that's 4 sig figs. Okay, this 0 right here is an example of a trapped 0, therefore it's significant. Okay, so we've got 3 sig figs. Okay, our third example right here, we've got 2 zeros, those are out in front, those are leading zeros. The only thing those do is hold the decimal place and tie the value to the label. Therefore this one has 1 sig fig. Okay, not a great measurement. Okay, now on this problem here we included every type of 0 there is. We've got a leading one, therefore it's thrown out. We've got a trapped one, it always counts. We've got a trailing 0 with a decimal. So what we have here is 1, 2, 3, and 4 sig figs. Okay. And finally, we've got trailing zeros with no decimal, so those don't count. So this one is 2 sig figs. Okay, hopefully your answers match that. Okay, now we've got to practice a couple right here where we actually do problems, but we have to discuss our rules. In Chemistry 1, we really only use the multiplication and division rules, which makes it easy. In Chem 2, we'll use addition and subtraction a little bit. I might show one quick addition subtraction problem here at the end. Okay, well, let's start with this. Okay, so the rule for multiplication and division use the least sig figs in the problem. Okay, we'll use the least amount of sig figs present in the problem. Okay, so I look at this, I see 8.9 times 10 to the 23rd. That exponent does not apply, right? All that does is make this a friendlier number to use. Okay, so we would look out here in front, so that shows me 2 non-zeros, 2 sig figs right here. 453 has 3 sig figs. Okay, there's 2 here, there's 3 here, and then 6.02 times 10 to the 23rd, it has 3. So the least amount present in this problem is the 8.9, so when I get my answer, I'm going to round this one to 2. Okay, now as we look at number 2 here, that's a leading 0, so it doesn't count. We go 1, 2, 3, there's 4 sig figs right there. There's 4 sig figs again with 0.7514. 273 has 3, and 5.25 has 3. So our answer in the end, we're going to round it to 3 sig figs. Okay, and then number 3 here, okay, I threw this one in because this is our first example of using definitions. Okay, this 68.3 is our only measurement. So our sig figs come from this. Okay, this is a definition or an exact number. Okay, same thing here. We don't count these. Your significant figures come from here. Okay, we're looking at 3 sig figs. Okay, so again, I'm going to have you pause it here for a second, plug these into the calculator. Please remember to use EE instead of your caret 10 to the, okay, or 10 to the caret. And then we'll go through and we'll discuss the answers to these here in a second. Okay, so let's look at these and work on rounding them to correct significant figures. So we'll plug this into the calculator. Okay, we get something that looks like 6.697 times 10 to the minus 18. But we've got to go to 2 significant figures. So I'm keeping that first 6. I look at the second 6 and I look at what's behind it. The 9 says I have to round up. Okay, so if we write this correctly to significant figures, it's 6.7. I have to keep that times 10 to the minus 18 to hold its value. Okay, this next one that we had to round to 3 sig figs. So if you're looking at, I think you get 3.206. Okay, this is another one. So you go to the third place. That's where that 0 is. The 6 behind it, we got another one that rounds up. Okay, so the correct answer here, the sig figs would be 3.21. Let's box in those correct answers. Okay, then on number 3, we're going to take this answer and we're going to round that one to 3 significant figures. Okay, we get something that looks like 7.3626 times 10 to the 23rd. Okay, if we want this one to be to 3 sig figs, I go to the third one, which is the 6. What's behind it? A 2. A 2 says round down. Okay, so we're looking at 7.36 times 10 to the 23rd. Okay? Alright, now, this is it. In terms of Chemistry 1, what we would worry about. Okay, Chem 2, sometimes we do have to deal with these addition and subtraction rules. Look at this one here really quick. It's a very simple example, but it gets the point across. When adding and subtracting values and then getting a sum or a difference to significant figures, okay, what you have to do is round to the least specific decimal place, the biggest decimal place found in any of your measurements. Okay, so what we have here is we're going to the hundredths. This is significant to the ones place. This is significant to the tenths. Okay, so we add this all up, and in the end, we're going to have to round to the nearest 1. Okay, so this is 0.72941. Okay, so now I look at this thing and I have to go, okay, I got to show that this is significant to the ones place. There's a 7 behind this 9, so I have to round up to 150. Now if I leave it like this, that doesn't tell me I'm significant to the ones place. Okay? To show I'm significant to the ones place, to make this trailing 0 significant, I have to add a decimal. Okay? And now this shows I'm significant to the ones place. And that, in a nutshell, is our significant figure rules.